A12 financial expectation today. Right, this is back to our probability for a little bit. This is the last little bit of it before we say goodbye to it, really, for your course. Now, financial expectation has to do with these probability things when we play some sort of game. The way that we calculate it is that we multiply the probability of each outcome by the outcome, which will be some sort of dollar figure. Okay, it's what we expect to occur in the long term. Right, sort of the average result of some sort of game. I think the best way to do this is to look and see how it works out. Now we've got this thing here. We're spinning a wheel. Let's say there's a 50% chance of landing on even. On even or 50% on odd. Now, my financial expectation is equal to the probability. Okay, so that's 0.5 times the outcome. And I've got to subtract also the cost of playing. So minus my $2. Oop. Doesn't cost $2 to play, it costs $1 to play. Okay, so that equals 1 minus 1 equals 0. So my financial expectation is $0. Is to neither win nor lose, but merely to break even. If I play that game long enough, I would expect to walk away with the same amount of money that I started with, neither more nor less. It may not happen that way, but that's what I should expect to occur. Now my next example here is a former HSC question. Okay, it's not multiple choice, right? Slightly more complicated. That's 2-marker here. So let's see how this works. I've got more than one outcome. So my financial expectation is the probability, so that's 1/5, times the outcome, $10. Now plus the next one, that's a 1/2, times the outcome, which is $3. Now the next one is 3/10. My outcome this time is not to gain $8, it's losing $8. So that's 8 times, oops, sometimes that should be plus, times, let's call it negative $8. Right, because it's losing. And I subtract the cost of playing, minus my $2. Okay, when I work all of that out, I get a loss, a negative, right, that represents a loss, 0.9, 90 cents. So my expectation, 90-cent loss. Right. Each game I expect to lose 90 cents. Right? On no game will I lose 90 cents, no individual game, because that's not an option, that's not a possible outcome. But in the long run, for every game I play, I expect to lose 90 cents. Okay, last one here. Now this is a little bit more complicated, we've got to read this carefully. I suggest you press pause, read this carefully. First thing I want you to look at here is my probabilities. There are going to be 4 outcomes. The probability then of the probabilities must add up to 1. So this final one here, 70, 80, this must be 20%. Right? Outcome 4 must be 20%. We've got to fill all of them up. Now what I need to work out is, what is the expectation of this occurring? That has to be equal to the expectation of the last one. Okay, equal but opposite, because these are all wins. I need to have my final expectation that I lose that amount. So what I'm going to say is, I'm going to say 20% of x, 20% times x, is equal to, all right, 10% of 12 plus, oh, I'm going to run out of space here, aren't I? 10% of 12 plus 40% of 6 and 30% of $3. Okay, that tells me that, let's say 20% of x equals, I think that's $22.50. No, it's not. I'm jumping the gun here. You can see that I've already worked out the answer. Equals $4.50. Right. These expectations work out to a win of $4.50, but I need to cancel it out. So 20% of some, whatever this loss is here, right, whatever that loss is, it has to cancel out those wins. Right? Now, if I multiply both sides by 5 there, I'm going to get 100%. Okay, that means that x, right, my unknown figure, is equal to 5 lots of 450 is $22.50. Is it $22.50 loss. Okay, so that's going to be lose $22.50. Okay, 12. I hope that makes sense. See you in class.